Good day to you from Anagalactic on Saturday, June 27th, 8 a.m. local time here in California. Over here, you'll see the force curve diagram that we have been discussing in the prior video. We're going to continue to look at that, but I wanted you to see the context of this diagram. I'm sure you can't read what's written above it, but I'm just going to read one paragraph. The maximum value of attraction for the strong nuclear force occurs around 1 femtometer. This horizontal black line is linear spatial separation between two protons, and there are 3 hatch marks, which are significant. There is the 0.5 hatch mark, where the strong nuclear force curve crosses the spaceline. The 1 femtometer mark, which I am indicating here, is directly above the nadir, and the 3 femtometer mark indicates where the strong nuclear force relationship between two protons begins to attenuate towards infinity. In other words, it's a turning point of that downward turning curve. What is being said here is the difference in the force relation at these 3 positions. The maximum value of attraction for the strong nuclear force occurs around the 1 femtometer mark. What that indicates is that if you read down from the 1 femtometer mark, it indicates the nadir, that is, the maximum attractive force. That's where the 2 protons are maximally attracted toward each other. So that's very important. The strong nuclear force is also known as the strong interaction. This is where it starts to get into gobbledygook. Already we have a compound term, strong nuclear force. Well, is it a nuclear force? Yes, because it's between 2 protons. Is it the strong force? That's where it starts to become extremely confusing, because that term, the strong force, has violently changed meaning. I dated it to the late 1960s when Gell-Mann, a nuclear physicist mathematician, made a fairly substantial discovery, I think one of the most significant discoveries to come out of the Hadron Collider experiments, which is of course to probe the proton. That's why the protons are being smashed together. It's not to increase our knowledge about subparticle structure, except to get at the force, because it's a military operation, as you're well aware. It has nothing to do with civilian interest in the universe. It has to do with a non-human and inhuman entity called a government attempting to get control of a yet stronger force for military power. That is inarguable, because all you have to do is trace where the money comes from, but the money talks. That's why this is so confusing to a layman, because there are 2 different interests involved. What you get in the media everywhere, it's a technological point of view. The strong force is different from the nuclear force. In this diagram, it is called the strong nuclear force, but you'll see that there is another curve which occurs entirely above the space line. But what is above and below that line is non-spatial. It's force. And that's all it is. It's not in space. I believe that's extremely difficult visually to get used to. It was for me. What I have been attempting to show is what this red line, electrostatic force, is doing in this diagram at all. It's not a nuclear force. Now what this is the modern definition of the strong force. I believe that this diagram says everything that a layman needs to know about the strong force as it's conceived by technologists. The key factor is the 3-ness. It is a trinary system. This was discovered by Gell-Mann. There is some validity here, and I just want to be sure that we leave this topic of the technological side with some understanding of some of the validity of what was discovered. It's called quantum chromodynamics. Chromo, of course, means color. And you'll see 3 colors there, the colors that are used simply to have a classificational portrait of what is being talked about with quarks. These are quarks. The word quark is extremely fanciful. It comes from the writings of Lewis Carroll, who wrote Through the Looking Glass and the Adventures of Alice in Wonderland. The word was made up by Carroll, Q-U-A-R-K. The co-discoverer of this trinary system wanted to call them aces. So there would have been 3 aces. But quark was just apparently just too difficult to resist, and so in a lighthearted fashion, it was conceded that we're going to call them quarks. But the key factor is that there are 3 of them. To draw something like this, it was conceived to assign a color to a quark. So they're called red, green, and blue. That's about as far as understanding can get, but I'll take you down one more level in Alice's rabbit hole. You'll see that it says UUD in a 1x3 column matrix. Down below it, it says DDU. That shows the trinary relationship. This symbol right in the middle, pi to the 0th power, you can completely disregard. That's just symbology. It really has no meaning, except, of course, to these technologists who think that this is the be-all and end-all of existence. It certainly is not. So what is shown here is in the upper part and in the lower part, it is connected by a 2-way arrow. One arrow pointing down, the other arrow pointing up. And that is now called, by the technologists, the strong force. It is a quark relationship. Now back to our less technologically oriented diagram of the strong force. You can see that down here on this diagram, labeling the blue curve below the spaceline, it says strong nuclear force. Now that is not the strong force. It is the strong nuclear force. An abuse of words. In other words, they've redefined it. No, they haven't. That is pure theory for the proton-proton interaction, which is all it is. So this diagram actually shows 2 extraordinarily different relationships between 2 protons. You'll notice that they're superposed, in the sense that on the horizontal aspect, these 2 curves overlap. In other words, they're describing 2 different relationships between 2 protons. The bottom one is what I call the strong force, which used to be the correct definition of that curve. It's called the strong force, which correctly defined is the relationship between 2 protons at femtometer range, indicated on this graph as going to 3 femtometers. 3 femtometers, let me indicate that with the pointer. This is the 3 femtometer mark. Now technically the relationship between the 2 protons is all along this blue line. So it doesn't end at 3 femtometers. But you can see that at 3 femtometers, this curve, which I'm tracing, goes from being strongly vertical to strongly horizontal and continues on from left to right on an asymptotic relationship with the spaceline. And what that means is that whichever force this is, repulsive or attractive, and just to be clear about this, this is attractive force. The blue line below the spaceline, which is from 0.5 femtometers to infinity, very important, to infinity on an asymptotic curve, that part of the curve has to do with attractive force, which is unnatural between 2 protons at any range except for this range, which is a little bit baffling, so let me illustrate how that is actually shown on this graph with the red line. What is the red line doing there? The red line shows, or ostensibly shows, attempts to show, if indeed it shows, which I'll show you it doesn't quite show, but intends to show the charge relationship between two protons, which you and I were taught in school. That plus charges repel. They repel. And that's why the red line, the red curve, is drawn exclusively above the spaceline. And there's no intersection. The blue line intersects the spaceline at 0.5 femtometers. Extremely significant, because at that point, which indicates that the two protons are at that distance, there's no force. No force. No strong force. But according to this diagram, when the two protons are that distance apart, 1/2 of a femtometer, you could read up to see what the electrostatic force, the red line force, would be at that point. And if you do read up, as I'm going to use the pointer now, you would read straight up to find out the intersection with the red line. And there is none, because this red line is asymptotic to the strong force line. And that is a very key insight, although it may not be clear to you what I just said. This, again, does not exactly make sense. So I'm showing you something that is actually erroneous, which is a remarkable statement. This is a scientific paper, and normally these kind of scientists would not intentionally mislead anybody with one of the diagrams with which they're attempting to show what they're trying to say. In other words, nobody's trying to lie. But let me show you what is actually shown here, which is quite extraordinarily confusing, because it's quite extraordinarily wrong. The electrostatic force is not superimposed on the diagram that we have been studying, which is strictly the blue line, from the Wikipedia article on nuclear force, not the strong force, but nuclear force. Because that diagram is showing what used to be called the strong force, and what I continue to call the strong force, but strong force has been pirated by the technologists. And so the strong force has two separate meanings, one of which would have to be said to be historical. That's the one that I use, because that's the correct definition of the strong force, but that's my decision. Am I justified in making that decision to revert to the old definition of the strong force? Well, I'm not even sure that you understand the question that I just asked. Of course, I hope you do, but I can't afford to take that chance. And now I wish to disambiguate the meaning of these two superimposed curves. There's a scale error, a very distinct scale error. And this is actually admitted in the literature, so I want to show you why this red line does not belong here. It's because it's superimposed at the wrong scale. Essentially, this red curved line does exist above the spaceline in a spatial separation horizontal aspect, showing what is the strength of the force between two protons at range. But at what scale? This shows the electrostatic force imposed at the same scale as the strong nuclear force, as it's labeled here, which is supremely ambiguous or supremely specific, depending on how you look at it. This is so hard to explain. I hope you're bearing with me, but I'm starting to become a little bit hysterical. I shall control myself. First of all, There is an electrostatic force relationship that has been discovered between two protons, but it's never been tested. In other words, it's very difficult to put two protons in proximity, for instance, and really specifically around 3 femtometers, to see which way the protons will go. Will they repel or attract? Which one would they do, if either, because there is a balance point. So what do two protons do when they're next to each other? Well, what do you mean next to each other? Here, what is being shown as next to each other is ranged around that 3 femtometer position. So you could easily ask the question, and this diagram should answer your question, what do two protons do? That's hard to say. What do two protons do if you place them 3 femtometers apart? It depends on which graph you consult. If you read up, as if they would experience electrostatic relation, you already know that they're going to repel. We were taught that in school. Because a plus, just think of them as pluses because all the textbooks show it that way, they have a positive charge with respect to the electron which has a negative charge. It's very important to complete that sentence because the plus and minus are not absolute qualities of the particles. They're relative to each other. That will become critical as we go on. I'm kind of seeding your mind for the synthesis. I hope I'm doing this well. I've been practicing well for 2 years to restate this relationship between two protons at any distance. What is their relationship? It depends on how close they are to each other. That's really the critical statement, so let me repeat that. What we want to answer is the question, what is the force relationship between two protons? Well, you have to be sure that you add another criterion because it depends on how far away from each other they are. It depends on their separation. If they're far from each other, on an atomic scale, if one proton were outside the range of a hydrogen atom, if it were further than the radius of an entire hydrogen atom, if the other proton were outside the range of a hydrogen atom, were there an electron there, that would be far. Now in this diagram, there are no electrons. So this is theoretic. And you might ask, has in fact the repulsive nature of two protons ever been directly tested? According to my recent research, no, that's never, because it's very hard to even imagine how you would test that. But it is logical to assume that they would repel. And that is in fact what is stated. Nobody denies that. So that's called the electrostatic relation. Really, in our language as laymen, it's the charge relation between two protons. But here you should add a clause to complete what we actually do know about that relation. Two protons naturally repel at every range, that is, at the scale beyond an innermost range, at which range another force takes over, called the strong force. And now you know why I had to disambiguate the word strong force, because this has nothing to do with chromodynamics. It has nothing to do with the quark trinary system. It has nothing to do with that. That's a technological innovation that has nothing to do with reality, to just be brutally honest. So we're not talking about the modern technological definition of the strong force. We're talking about the traditional Bohr atom. What we actually do know about the atom is that the traditional view of the charge relationship between two particles is that two protons will repel because they have the same charge. And the same is true of the electron, that two electrons will always repel. So that is a fixed relationship between same type charged particles, of which there are only two. So what happens? There now remain two questions to be answered, because two negative charged particles, electrons is what I'll call those, because that's what they are. Two electrons repel and two protons repel. But in the case of the proton, and only the proton, that relationship changes at small scale, which here is depicted as ranging around the 3 femtometer mark. Really, it's inside the 3 femtometer range that the force relationship changes. And now I direct your attention to just the blue line. We are now going to disregard the electrostatic force line. And I'm so glad that I found this diagram where they're superimposed, because you might suspect that that electrostatic force line is misdrawn. Yes, it is. It should not be curving in this range. It should be way over to the right. And that, you might challenge that because you respect authority. And I'm challenging the authority of this diagram as if I were smarter than this physicist or team of physicists. I hate to do that because it really puts me in the lurch. It puts me in jeopardy. You may say, well, that's just crazy. You're megalomaniac. You're pretentious. You're correcting the physicists? Who the hell are you? Speaking of me. But that is, in fact, what I'm going to show you. But in order to simplify this, which is, of course, our goal, is to get to actually know what the right answer is. They don't know what the right answer is. That's what I'm implying. All right. All right, and now we've returned to our primary diagram, our target diagram, which does have a fairly accurate representation of the strong force, now that we've disambiguated that term. But just to let you know how this is labeled, in the Wikipedia article, it is not called the strong force because they abide by what the technologists say. But I call it the strong force because, quite frankly, that's what it is. But Wikipedia translates that for me to modern lingo, where if the strong force has been redefined by chromodynamics, the quark relationship, then what is this? What do you call it, since you can no longer call it the strong force? Wikipedia calls it the nuclear force. In the prior diagram that we just looked at, which contains this, it was called the strong nuclear force, which just shows complete confusion among the physicists. They can't agree. It's almost like it's every man for himself, but I want you to understand it's merely a contest between traditional science and a spin-off of science, which is not what we want. And chromodynamics is not at all what we need to know anything about, except what I will tell you. Again, pretentious? Somebody has to do this, and I've undertaken to do this on behalf of all science, because I do understand this. So I'm going to get you to understand it as well. This is the curve of binding energy between two protons at close range. So instead of calling it the strong force, which obviously entails a difficulty, almost certain to raise confusion, especially if it were a large audience, statistically it would break into two groups who would hear strong force and interpret it in two completely different ways. That's unacceptable in scientific communication. So somebody has to lay down the law here. And I offer a compromise which I think is perfect. This is the curve of binding energy. The curve of binding energy. That's actually the title of a book by John McPhee. And if you want to know more about that, just leave a comment or look it up yourself. But I will give a video presentation on what John McPhee meant by that, because I'm not using the term exactly the way John McPhee used it. And John McPhee literally has no idea what that is. He simply was interviewing particle physicists, that is nuclear physicists, back in the, I say 1970s, but I believe the book came out in the late 1960s, The Curve of Binding Energy. And I read that book a few decades ago. It is a disturbing book because it's actually about the prospect of making a amateur nuclear weapon. And that really raised a lot of controversy, but we don't want to go there. That's really more or less a folktale, which I just found ultimately fascinating, but it's an extremely disturbing book, and it was taken as such. The main character in his book was the greatest nuclear physicist of his age, and he was directly responsible for improving nuclear weaponry technology. He was highly respected, but he kind of lost his mind toward the end of toward the middle of his career. At the height of his power, he was one of the most valued military technologists in the history of the United States. But you see, he became more or less an eco-freak. It's the only way to put it. He started saying, based on his knowledge of how to construct a nuclear device, he said it's just a matter of time before amateurs, in other words, without intervention of the government, who normally would control the proliferation of those devices, it would get out to the public, who would then start blowing them up in all of our cities anywhere in the world. And he was convinced. He didn't say that this might happen. He said that it was going to happen. That has since been debunked to a certain extent, and really the issue has been suppressed because it's too disturbing. It goes well beyond mutual assured destruction. It would be like anywhere that you care to live, somebody could have a suitcase bomb that could literally kill thousands of people with one explosion easily. And it's still debated whether that's possible. So that's the nature of The Curve of Binding Energy, a book by John McPhee, who normally writes about geology, and he got the highest awards of all for his books on geology. But he's also written about basketball, and he's written about quite a few. He's quite a prolific author. I think John McPhee is right up there with some of the greatest American nonfiction authors. All right, so back to our topic. I love to tell stories. I hope you enjoyed that. That's where I acquired this name, this term, for the strong force, because you can't, in my opinion, that should. I wanted to continue to say strong force, but I don't think that's a good idea because of the level of confusion in that term. Science should not be confusing. The whole purpose of science is to bring understanding. It's kind of like in politics, to bring peace. Well, I think that's a pretty good parabolic metaphor. In other words, a metaphor going to a parable, that politics and science are very closely related in the sense of deceptive activity, deception, both in science and in politics. It's glaringly apparent. Anyone who knows anything knows that science is really the art of deception now. Everywhere on YouTube, you're simply being lied to. Consistently, and strategically. You're being lied to by professionals. And what makes it so strange, so just a little bit different from politics, where at high level the politicians certainly must be aware that they're lying. They simply will lie because that's how you get power and money. But in science, you wouldn't expect that. And so guys like Neil deGrasse Tyson, who's an asshole and a liar, it may be that he's not fully aware of what he's doing. Another example is Brian Greene, who's a Jewish mathematician, very high-profile Jewish mathematician. I believe that he's a professional deceiver. In other words, he knows what he's doing, but he pretends that he's just completely innocent. To give you just one more example, because this has a human side that you should be aware of, this is really more important than science, is that in two other fields, namely geology and biology, systematic propagandization and deception is the norm. There is such a thing, as you know, when I was growing up, it was called Darwinian evolutionary theory. And although it had been around for 150 years, you may not believe this, but when I was in high school, it was still being called a theory. In other words, nobody was saying that anyone was absolutely sure that Darwinian evolution was a fact of nature. Nobody was sure. I mean, that's why you used the word theory. Well, in my lifetime, that changed dramatically, where now it is taken for granted that Darwinian evolution is a fact, and nobody will ever deny it because it's been proved. And that's a lie. The other one, very closely related, a systematic deception, taught in all schools in the United States certainly, is in geology. When I was growing up, it was still admitted, although not as strongly, that the millions of years model, really a framework for analyzing geology, goes back 4 billion years. Now, at one level, that's undeniable because the sun is 4 billion years old, and we know that that's true from studying stellar evolution, which has been proved. No question, stars are billions of years old, and the sun is approximately 4 billion years old, because we know what type of a star is our sun. And therefore, the age of the rock on Earth is on the order of 4 billion years old, and nobody should question that. By the way, there's a movement in religious circles which is attempting to be scientific, which of course is their right. It's called the Young Earth Creationists, usually abbreviated YEC. It's important that you know all these things. I'm not trying to brainwash you to join some goddamn church, or one way or the other. This is science, pure rational logic. But you should know the human side because of deception. Systematic deception, where in geology, first of all, the rock of Earth is obviously billions of years old. That's a fact. But what about the sedimentary rock layers? The sedimentary rock, sandstone, limestone, and there are other forms of sedimentary rock which cover the continents all over the world. And that's not 4 billion year old rock. That's sedimentary rock that has to be laid down by some geological activity. So how did the sedimentary rock cover the Colorado Plateau, for instance? Why is there sedimentary rock at the very top of Everest? I don't know if you are aware of that. Men who get to the top of Everest, men and women, of course, whenever I say men, I mean men and women, who get to the top of Everest are standing on limestone. I don't know if you're aware of that. Just a couple of thousand feet below the top of Everest are fossils from the bottom of an ocean. How did it get up there? So that's what is meant by geology. There is simple rock geology. How old is the rock of Earth? Well, even the sedimentary rock, that is, the crystals, the components of sedimentary rock, are as old as the solar system. But everyone knows that. But that's not the question. The question is, how did the sedimentary layers get layered? And there were two theories about how that happened. Although in my lifetime, no one knew that it was because of a flood. Although religionists, Christian and Islam people, believe that Noah's flood actually occurred, but there was no scientific proof of it. In my lifetime, that scientific proof was discovered, and you're not allowed to know that. It's in Wikipedia. There's dozens of books on it. It has been shown that the sedimentary rock layers around the world were laid down by the flood. And that's finally been admitted by mainline geological experts. In other words, that is consensually accepted, that there was a flood, but it wasn't Noah's flood. No Western scientist will ever admit that unless they're Christian or Islam. Islam is not normally associated with the West, but Islam does believe in Noah's flood. Protestant Christians, and really also Catholic Christians, have always believed in the flood, Noah's flood, because it's in Genesis. But there was never any scientific proof of it. No one ever correlated the fact that the flood, Noah's flood or otherwise, might have caused the sedimentary layers to form all over the earth, including our own Colorado Plateau here in North America, where there are fabulously thick layers of sedimentary rock. Just the Navajo sandstone is one of the most outrageously magnificent, awesome, and overpowering phenomena you will ever see in your life. And this is why going to the Grand Canyon is really something everyone should do. But you don't have to go to the Grand Canyon. You can go anywhere in the world and see huge, really even mile thick, layer after layer after layer of sedimentary rock. Well, finally, the discoveries made by Walter Alvarez and then the subsequent correlation of a cosmic event, the Earth was struck by a comet or an asteroid. But then you see Noah's flood would state that that was about 6,000 years ago, and no Western science, no modern Western scientist outside of these fringe groups, such as the young Earth creationists, would ever admit that. They'll never admit it. And so that's actually illegal. You're not allowed to say that that flood was 6,000 years ago. But it has been admitted that there was a flood. And you can look this up in Wikipedia. It's common knowledge. And they'll even teach you, the government officials that monitor the Grand Canyon will tell all the little children, the Boy Scout groups, and whoever else, any family from anywhere in the world, they'll tell you what those geological strata mean. When you look out at the Grand Canyon, you see multicolored layers of sedimentary rock. Well, how did they get there? It's not exactly admitted that it was by a flood, but it is admitted that it had something to do with the Earth having been flooded 65 million years ago. That's incredibly important to the propaganda machine. It had to be 65 million years ago, not 6,000. But it's also been proved, and you can check this if you look carefully, that it actually was less than 10,000 years ago. It's glaringly obvious that it wasn't millions of years ago. Or why are there fossils? Well, there's an explanation for everything, but there's just lists that go on for pages and pages of how come it doesn't look like it was millions of years ago. And the propaganda machine is very meticulous in stating their answer to each objection, where it doesn't look like, Ranger Rick, that these sedimentary layers were laid down on the order of tens of millions of years ago. It looks like they were laid down much more recently. And that actually has been proved. It's really glaringly obvious once you know the salient facts. But these are levels of propaganda that are just outrageous. The Big Bang, the cosmological model, including all these strange terms such as dark matter, dark energy, and even the supermassive black hole, are just pure lies of propaganda, is how they're interpreted. There was no Big Bang. The supermassive black hole does not swallow light. There's very little that's actually known about the supermassive black hole, except I know the geometry of it, which gives the actual understanding. As for the Big Bang, you'd have to be out of your mind to agree with what all the physicists agree on. They say there was a Big Bang. No, there wasn't. It's just that simple. No, there wasn't. By the way, that as far as biological evolution goes, it's a little ambiguous to a layman, which I'm not. I'm a professional. Is there any truth to speciation, which is the correct term? It's not evolution. That's a stupid word. It's too abstract. It's speciation. That was Darwin's theory, speciation. The change of species over time to have more and more species. Is that true? It depends on if you're talking about humans, which is a special case, or the plants and animals, what we call the ecology. I can prove to you that Darwin was right about the finches, by which I mean, emblematically, the plants and animals did speciate. They did speciate, but it's impossible. They couldn't have. It's just that they did. There's no mechanism, and there's no evidence of speciation, except for the direct observation of Darwin and others, that if, for instance, you go to the Galapagos Islands and look at the finches, it's obvious that they came from a superfinch. And that proves, by visual, just looking, there was speciation. But there's no way it could have happened. So it was supernatural. And that's the correct answer. That the animals and plants were speciated a second time, and that's not in the Bible. So your Bible is a lying document. And your sola scriptura of the hard-nosed Protestants, they're all under the sway of an extreme propaganda program in mainline Christianity. That the idea of combating speciation with flood chronology is misguided because they're idiots. In science, you have to get the facts, honey, that you can't just thump your Bible. I do believe in the biblical record, but you have to know what to believe in that record. And I'm the world's foremost expert on the Bible. And I will go up against anybody on that, and I'll tear you a new one if you come against me too strong. Otherwise, we can have a friendly debate where you'll learn from me, but I will never learn something from you. And that's also the case here in this curve. So I wanted to show you that systematic deception in science is across the board. Across the board. I just gave you 5 examples of Nazi propaganda. It's Nazi level. And it goes to the children. This is torturing children. Just as the physicists, mathematicians, designedly or not, are responsible for torturing millions of children with calculus. And it goes well beyond that. These men are out of their minds. All scientists in the West are now, for the reasons I just gave. There's not one scientist that I know that can refute all 5 of those deceptions. Instead, they promote them. That man does speciate, which is a lie. That maybe there was a flood, but it was millions of years ago. That's a lie. That there was a Big Bang. That's a lie. And then you go to the standard model of particle physics. That's a lie. So what is true then? We're coming up on an hour, so I'm going to wrap this up. I really am quite emotionally committed here, and I think you can hear it in my voice and in my tenor. I'm angry. I'm furious. I'm jealous. Because truth will set you free. But these assholes like Neil deGrasse Tyson and Brian Greene, all of them, Sean Carroll, but it's all of them. They all are liars. Are they guilty of subterfuge? It would have to be evaluated on an individual basis. I can't make a blanketing statement except what I've said thus far. They are all notorious liars. All of them are. They all lie. That's all they do is lie. So this really, really stretches me. Because right now I'm trying to get one piece of the puzzle, which is the structure of the atom. When I was in school just a few decades ago, the structure of the atom was well understood, although it was changing rapidly because of men like Gell-Mann and Feynman. Feynman is a notorious liar. By the way, all of these men are atheists, without exception. Hundreds of thousands of them. And they all have white skin. And if you raise the objection that Michio Kaku does not have white skin, I will take you to the cleaners and make you beg for mercy at my feet. Yes, he does have white skin. And so does Neil deGrasse Tyson. Neil deGrasse Tyson is not African. He's not black. And Michio Kaku is not Japanese. They're white supremacists. And don't you ever make any mistake about that, or you're not going to understand what's going on in global politics, on which I'm giving concurrent video presentations. And that's coming up on an hour. So what does this diagram actually show? It shows the force relationship of two protons inside the electrostatic range. And therefore, it can be shown that this Wikipedia diagram is false. It's wrong. And that's part of the reason for the mistake that I made 2 years ago. This curve, which I now am showing you with the pointer, indicates that at the inmost range, right here at the 0.8 femtometer mark, where the blue force line crosses the space line, when there's a proton here, and the other proton is here at the 0, 0, I've covered this in the prior videos, so you should be able to keep up. Actually, you don't need those videos. One of the protons is at the 0, 0, inertial frame, no velocity. This proton is as close as the proton can get to this proton, because there's no force. But which is the repulsive? This is the repulsive side. What's above the line shows repulsive force. This line dipping down, coming in from the right to the left, shows increasing attraction, which is the opposite of the electrostatic relation. Normally protons repel, and that should be shown in the continuation of this curve. In the Boshkovich force curve, it is shown. It is shown. But it's not shown for the proton-proton relationship. It's shown for the proton-electron relationship. And now we're going to have to desist, because I'm sure that I confused you, and I told you that I would. This is the most confusing, baffling, paradoxical relationship ever discovered by man. And it leads directly to quantum entanglement, and it leads directly to everything that we don't know about the photon, either as a wave or as a particle. I have all the answers. So I hope you tune in, and I just want to close off by telling you that at this close scale, it's accurate enough. Well, it is very accurate from the 3 femtometer mark, which is right here. That's the 3 femtometer mark, which you saw from the prior diagram. When it's 3 femtometers away from the other proton, and there's no Newtonian force anywhere, this is with no electrons either anywhere, that if you start action and it's no longer static, this proton will start to move toward the other proton by attraction. And as it proceeds along the spaceline, it accelerates. It is accelerating. And it's accelerating all the way to the 1 femtometer mark. It's accelerating. And when it goes past the 1 femtometer mark, it's no longer accelerating, but it has velocity, which decreases asymptotically as it proceeds forward. At that velocity, it's now slowing down. It still has velocity, but it's slowing down. And when it reaches this mark, if it still has velocity, it can go forward. But if it does, it'll be pushed back. And we'll be right back. Thank you very much for tuning in.